Okay, all right, okay, welcome back. Right, like cycle bin love to say, let's take a 5-minute break. All right, okay, we took a break and we came back. Right, our next step, what we're supposed to do here, right, we're supposed to draw the shear stretch diagram in order to figure out where is the maximum bending moment, right? Enjoy the maximum bending moments, right? So that we can figure out where is the maximum bending moment, right? Now, looking at this question of ours, this tension, they're pulling in the z direction, right? And then we have the weight that is in the y direction. So that means we have two faces, right? So we're gonna start with the y-x face, right? So this is the, let me just the xy, which is the vertical. This is not here just for show. I'm actually drinking it. We're monstering. Real nigga shit. Yes. Okay. Let's focus. Like I said, we have our shaft here. This is our shaft. Right. This is our shaft. Wait. Don't write on top of the papers. You're gonna mess it up. Okay. Let me just put these ones here. Yes. We have our shaft. And then this is in the xy. This is in the vertical, right? And one thing you have to know, in the vertical direction, the bearing will always point upwards. So let's start with those ones, right? This is bearing A, and here we have bearing C, right? And then here we'll have the radial plus the weight of the gear, right? And then here the pulley, if we had no mass of the pulley, then here there will be nothing. But then here, because we're given the mass of the pulley, we have to consider the weight. So here we're only gonna have the weight of the pulley, right? This is A, this is B, right? This is C, and then this is D, right? This is 0.12, is 0.08, and this is 0.1, right? Okay, this is R A Y, and this is R C Y, right? And then here we have the weight plus the radial, because I told you the radial on the case acting vertically downwards, and also you have to add in the weight. But then if you was not given the mass, you just consider only the radial, right? And also here we also have the weight, right? This is the gear, this is the pulley. Okay, right now let's solve for this RAY and RCY. Strength to, yeah, right, vertical is equals to RAY, right, plus RCY, right, is equals to, no, minus, no, okay, it's equals to, yeah, it's equals to, it's the same thing. The weight of the gear, we calculated the why, because we're smart. Yeah, you smart, you loyal. Little nigga shit, right? The weight of the gear is 74.48 plus the radial force calculated also is 321 21.81, and then plus the weight of the pulley. We also calculated that is 98.1. Let me put this here. 98.1. Yeah, let me just put this here so that I can clear things up so it doesn't confuse you, bro, because I know I'm helping you out here. Right? Okay, now let's consider the moments, right? And we're taking moments about, let's say, C, right? So it's gonna be R A Y multiplied by the distance 0.12 plus 0.08. I know the answer, but I just don't want to make mistakes. Yes, it's not like I can't add 0.12 and 0.08. I know, bro. I know it's 0.2. It's 0.2, right? Because you're holding this. Let's assume that you're holding it here. So this one's gonna be positive. This one is gonna be negative, right? So it's gonna be minus adding all this, adding the weight and the radial, which is 74.48 plus 321.81. Okay, 74.48 plus 321.81. Total is 396.29 multiplied by 0.08, right? And then the weight of the pulley going in the same direction. It's gonna be plus the weight of the pulley is 98.1 multiplied by the distance, which is 0.1, and all of this is equals to 0, so we can solve. Okay, let me just equals to 0. Yeah, equals to 0. So we're solving for RAY, right? So RAY is equals to, let's just add everything and then change the sign, put it next to y. So it's gonna be minus 396.29 times 0.08 plus 98.1 multiplied by 0.1 is 21. So it's gonna be 21.8932 over, don't forget 0.2. That means RAY is equals to 109.466 Newton. Here RCY therefore is equals to coming back to this here, 74.48 plus 321.81 plus 98.1, right, which is 494.39 minus, we're taking the RC, we're taking the RA into that direction. It's gonna be minus 109.466. That means RCY is 494 minus 109.466 is 384.924. Here, Newton. Don't forget the units. Do not, one of those lectures, they'll be like, if you do not write, why am I doing it? Nah, bro, don't do that. Those lectures where they say, if you don't write the units, then you're getting it wrong. Yeah, I'm one of those niggas. Yeah. So it's 384.924 Newton, right? And then let's draw the shear stress diagram. My favorite part. Why? Because it's the easiest part. Okay, coffee says easy. Let's see you do it. Oh, let's see. Okay, let's focus. Right, nigga. Yeah, nigga. Boom. 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 Plus I know the values 0.12, 0.08, 0.1. You gotta enjoy, bro. You gotta enjoy. You gotta enjoy. Okay, here is the weight plus the radial. Why? Because it's the gain. The weight plus the radial is 74.48 plus 321.81 is 396.29, right? And then here's the weight of the pulley. It's 98.1, right? And then here is RA. RAY is 109.46, right? And then here is 384.924. all right. Okay, I'm gonna try and make it as clear as it could be, nigga. Okay, going down, we go down in the deal. Yo, if you know the song, we go down, we go down in the deal, we go down in the deal, we go down, we go. All right, let's focus. This is the shear force, this is the bending moment, right? Here, you know what's nicest about these ones? Because the shear stress diagram, the diagram is straightforward. It's 109.46. Let me say it's 109.46, goes up to here, right? And then you go straight, right? And then you minus the 396, 109.46 minus 396.29, which is comes here, which is minus 286.83, right? And then you come here. It's like the aviator eating your money. Plus 384.924 because of the RCY. It's positive, it's going up, right? Plus, look at that, 98.1. 90, so that means here is 98.1. Right, and then 98.1, and then it minuses, then it goes down to 0, right? This is real nigga stuff, bro. This is real nigga stuff, nigga. Real nigga stuff. Okay, now let's fill in the moments. Bending moments at A and at B, at C and at D, at A, at B, at C and at D, right? Okay, now one thing you have to know, at A is 0. It is 0. Trust me, right? And then now you have to find the bending moment at the way, nigga. Okay, let me just, I'll think of the thing, you know, so that. Okay, the bending moment at B is gonna be 109.46 multiplied by the distance, right? Positive 109.46 multiplied by 0.12 is equals to, and then the bending moment at C is gonna be 109.46 multiplied by the whole distance, which is 0.12, 0.2, right? And then minus this, let's go in the opposite direction, minus 396.29 multiplied by this distance, which is 0.08, 0.08, right? Okay, bro, we could have moved it here. Okay, shit, right? And then also the bending moment at D, it's gonna be 0. Yeah, also here it's gonna be 0. It has to come back. Either way, you're gonna have to come back here. You start here, you will come back here. Okay, yeah, 0 Newton meter. So the bending moment at B is 109.46, 0.12, 13.135 Newton meter. And then at C is 0.2 minus 396.29 multiplied 0.08. It's minus 9.81. Let's get it real. Okay, because this here I know I have space, right? And I'm just gonna write this here. At C is equals to minus 9.812 Newton meter. At C. Let's keep it real. I'm not broke. Let's keep it real. I'm just keeping it real. Alright. Now we have the bending moments, which you can sketch them down. We have here, it's gonna be here at B 13.13, 13.135, and then here it's gonna be minus 9.81, which is minus 9.812. Like I said, it's easy. Just gonna wait. Gone. Your money gone. And then here starting at 0. Right? Okay. Blame. Kapow. Done. In the right direction. Right? Now we're going for the one in the Z direction. Like I said, we were doing this one, the XY, we're doing the XY, right? This is the XY, and now we wanna do the XZ, right? In the next video we're gonna do the XZ, and also we're gonna find we also want to find where is the maximum bending moment, and then end by finding the diameter, and then we'll be done. I know you're tired, but then just bear with me. We almost there, bro. We almost there. It's gonna be worth it at the end. So we'll see you in the next video. I'm out.